All right, in this example 5, we want to find the number n so that our nth partial sum approximates the true sum of this convergent alternating series to less than 10 to the negative 3. So this series is convergent because it does pass the alternating series test. Our series term, a sub n, is given by negative 1 to the n minus 1 times the positive part of our series terms, which is b sub n, and b sub n is just 1 over n. This sequence, b sub n, is positive, decreasing, and converges to 0. So those are the 3 hypotheses of the alternating series test. So this shows that it converges. So now we want, by the alternating series estimation theorem, we want the true sum s minus a partial sum to be less than the first omitted term. Excuse me, to be less than 10 to the negative 3. That's what we want. But what do we know? We know by the alternating series estimation theorem that this is always less than the first term omitted. So really, I had an error in my last video. Thankfully, didn't change anything. I wanted to select this to be strictly less than this amount. As a matter of technicality, you could pick it or equal to. You could pick it or equal to. Because this inequality is strict, at the end of the day, if you have a list of inequalities or equalities, you have to take the strictest one. So from this term to this term, the strictest inequality is this. So we would have to use this. So even if we choose b sub n to be less than or equal to 10 to the negative 3, that would still force this to be strictly less than 10 to the negative 3 because this term, because this term is strictly less than that term. So that chain of inequalities, you have to take the strictest of whatever appears. Okay, so we know what b sub n is. It's 1 over n. So this right here becomes 1 over n plus 1. And 10 to the negative 3 is 1 over 1,000. So doing a little bit of manipulations, we find that we have to choose the value of n to be greater than or equal to 999. So we want to pick the smallest value of n that works, so we would choose n equals 999.